Okay, hello everyone. I wanna talk about section 1.7, the linear independence today. So you can watch this video, the section 1.7. So if you have any trouble, any question, to stop by my office or send the email to me. I can help you. Hey. Here. Today, I want to talk about section 1.7, the linear independence. This is outline. I want to talk about the definition of linear independence and linear dependence, the linear independence of matrix columns, the set of one vector, set of two vectors, a set containing the zero vector, a set containing too many vectors. I can talk about the 6 kind of things today. The first one, definition of linear independence and the linear dependence. A set of vector, the v1, v2 till vp in Rn is linearly independent. If the vector equation x1 vector v1 plus x2 v2 plus xp vp equal to 0 has only the trivial solution. The note. It will only have the trivial solution if there are no free variables. That is, every column has a pivot. So this part is exactly same to the previous section, section 1.5, exactly same to the previous section. A set of vector v1, v2, v3 is Rn is linearly dependent. The vector equation x1, v1, x2, v2, xp, vp equal to 0 has a non-trivial solution. So it will only have the non-trivial solution if there is a free variable. That is, every column does not have a pivot. So this is make sense? Yeah. So do you know, you can change this one to the matrix equation. So what's that? So this one is the matrix equation. So this is like matrix A is vector v1, vector v2, vector vp. This is like this one times vector x1, x2, xn equaled like vector 0. Is right, vector 0. So this is exactly same to this one is matrix A. This is the vector x. So we have A times vector x equal to 0. Exactly homogeneous linear system. Homogeneous linear system. Homogeneous. So do you remember the section 1.5? The homogeneous equation, this is a matrix equation, has the trivial solution, only trivial solution. So what does it mean? There is no free variable. If you change it to the augmented matrix, is right? You can change it to the augmented matrix, like this. So this one doesn't have doesn't have a free variable. In other words, every column has a pivot. This is like exact meaning. Was it like linearly dependent? The same. You can change it to the homogeneous matrix equation. So was it like this equation has a non-trivial solution? So we have a free variable. So what does it mean? Every column does not have a pivot. Pivot. This is like exactly same to section 1.5. This is like a definition of linearly dependent, linearly independent. So this is like example. Determine if the following vectors are linearly independent. So how can you do that? So you can change this one to the what? Like this. x1 vector v1 plus x2 vector v2 plus x3 vector v3 equal vector 0. So this one has trivial solution, only trivial solution or non-trivial solution. This equation has only trivial solution, linearly independent. This equation has a non-trivial solution, the linearly dependent. So what does it mean? You can change this one to the matrix, the V1, V2, V3 times vector x, x1, x2, x3 equal to what? 0, 0, 0, 0 vector, like this. So I can change this one to the augmented matrix. You can change it to the what? Augmented matrix. I can do that. So we have the first column is vector V1, 1, 3, 5. The second column is the vector V2, the 2, 5, 9. 2, 5, 9. The third vector is V3, the negative 3, 9, 3. And this homogeneous equation, we have 0, 0, 0. So you can check. We have a free variable 1 hat. The free variable 1 hat. How can change? This one change it to the echelon form. Echelon form. So this is the first row, second row, third row. You have to keep first row 1, 2, negative 3, 0. So how can you sum the element of the second row? The next one. The second row plus negative 3 times first row. So you calculate like this. 3, 5, 9, 0 is the second row. The negative 3 times the first row. The negative 3 times 1 is negative 3. The negative 3 times 2 is negative 6. The negative 3 times negative 3 is positive 9. The negative 3 times 0 is back 0. And add. So we have 0, minus 1, 18, 0. So we have 0, minus 1, 18, 0. So like this. The next one. How can you eliminate the 5 from the third row? The next one. The third row plus the negative 5 times first row. The third row is 5, 9, 3, 0. The first row times minus 5. The minus 5 times 1 is negative 5. The 2 times minus 5 is negative 10. So the negative 3 times minus 5 is 15. And add 0, minus 1, 18, 0. So we have 0, negative 1, 18, 0. The next tip. So you can change more simple form, like echelon form. To eliminate this minus 1 to 0. How can you do that? You have to keep the first and the second row, 1, 2, negative 3, 0, 0, minus 1, 18, 0. So how can some eliminate this minus 1 from the third row? The next one. This is like a first row, the second row, and the third row. The third row minus second row. The third row is like negative 1, 0, negative 1, 18, 0. The minus 1 times the second row is 0, 1, minus 18, 0. You add these two rows, the 0, 0, 0, 0. So we have 0, 0, 0, 0. So what happens? The first row has pivot 1. The second row has pivot minus 1. Third row, no pivot. No pivot. So what does it mean? The x3 is free variable. Free variable. So what does it mean? This linear equation has free variable. This form is a free variable. What's that? The linear equation has non-trivial solution. This meaning is like x1, w1, x2, v2 x3 v3 equal to vector 0 has a non-trivial solution. Non-trivial solution. So this is exact definition of linearly dependent. So what's that? So the vector v1, v2, and v3 are not linearly independent. Linearly independent. So what does it mean? So this one are linearly dependent. Linearly dependent. That's it. This is whole idea for solving this problem. The next one. Determine if the following vectors are linearly independent. We can use same method. The same method. So you can change argument to matrix. What is like argument to matrix? The matrix. So you can change V1 0 to 2, 0 0 minus 8, minus 1 3 1. The next two. This is like a homogeneous equation. You can write constant part 0 0 0. The exactly same to previous example. So like so, the change. The next two. So you can change this one to the like echelon form. You can change it to the echelon form. The how can change this one to the like echelon form? This is idea. You just only interchange first law and third law. Interchange first law, the third law. The third law is 2, -8, 1, 0. The second law is 2, 0, 3, 0. The first law is going to a third law. So we have 0, 0, -1, 0. The next two. This is like a first law, second law, third law. You have to eliminate these two from the second law. How can you do that? The second law plus -1 times first law. Second law is 2, 0, 3, 0. The first law times -1, 2 times -1, -2. The -8 times -1 is +8. The 1 times -1 is -1, 0. So n add 0, 8, 2, 0. So what's that? This is same to 2, -8, 1, 0. The second law is 0, 8, 2, 0. Third law 0, 0, -1, 0. So you have to sum the exclude constant part when you think about the first three columns. The first column has pivot. Pivot. Second row has pivot. The third row has pivot. What does it mean? So we don't have a free variable. No free variable. So what does it mean? So this meaning is the x1 times vector v1 plus x2 times vector v2 plus x3 times vector v3 equal to vector 0. The homogeneous equation has only the trivial solution. The trivial solution. So what's your final answer? These vectors, vector v1, v2, v3 are linearly independent. Linearly independent. Like this. This is whole idea. The next is determine the value of h, then make the following vector linearly dependent. So what does it mean? We have free variable. We have free variable, same. You can change it to the augmented matrix, same. The matrix. So what's that? This is first column is v1, 1, -3, -5. Second one, -3, 9, 15. The third one, 2, -5, h. This is like a homogeneous equation, 0, 0, 0. You can change it to the argument matrix, like this. So what's that? You can change it to the echelon form. So how can I have the -3? This is like a first row, second row, third row. The first one is like this one. Second row plus 3 times first row. The second row is -3, 9, -5, 0. The 3 times the first row. The 3 times 1 is 3. 3 times -3 is 9, -9. The 3 times 2 is 6. And 0. And add it. 0, 0, 1. So first row is you can keep. The second row, 0, 0, 1, 0. Third one, how can you sum the -5? The third row plus 5 times first row. The third row is the -5, the 15, h, 0. 5 times the first row, 5 times 1 is 5. 5 times -3, -15. So 5 times 2 is 10. So 5 times 0 is 0. And add it. What's that? 0, 0, h plus 10. Here, 0, 0, h plus 10, 0. So what happens? This one is pivot. Pivot. What's the second row? No pivot. No pivot. So what does it mean? The x2 is free variable. So what's like value h? H is any number. The h is like -10. This is also 0. The also 0. But this is like pivot 1. h plus 10 is like non-zero. This is pivot, so it doesn't matter. So we have some kind of things. What is the like answer? This homogeneous equation has free variable for any h, the independent on h values, right? H like 10, the -10, 1, 5, 6, any number. This is always no pivot in second column. So what's that? This is the linearly dependent for any real number h. This is answer. Was it like h, any real number, any real number. The next one, the similar. You can change it to the augmented matrix. How can change? So like this. So we have 3, -6, 1, -6, 4, -3. 9, H3. You can change it to this one, and 0, 0, sorry. So this is like argument matrix. We need 0, 0, 0. 0, 0, 0. So like this. So I can do that. So this is like some of the best way is this one. The 3 and 1, the 1 is like a small number. You can interchange the 3 and 1. You can interchange the first low and the third low. So we have 1, 3, negative 3, 3, 0, negative 6, 4, H, 0. The last one is like a first low, 3, negative 6, 9, 0. We have this one. The next two, this is like a first low, second low, third low. I can eliminate minus 6. The second low plus 6 times first low. The second low is negative 6, 4, H, 0. Add 6 times the first low. 6 times 1 is 6. 6 times negative 3 is minus 18. The 6 times 3 is 18. The n 0 and add. So we have 0, negative 14. The h plus 18, 0. So what's that? The first row is 1, negative 3, 3, 0. What's it like the second one? 0, minus 14, h plus 18, 0. The next two, eliminate 3. How can do that? The third row plus negative 3 times first row. The third row is 3, negative 6, 9, 0. The negative 3 times the first row, negative 3 times 1 is negative 3. The negative 3 times negative 3 is positive 9. The negative 3 times 3 is the minus 9 and 0. And add it. This is 0, 3, 0, 0. So we have 0, 3, 0, 0. So we have this one. So like this. So what's like the best way? Interchange the second row, first row. You can change 1, negative 3, 3, 0, 0, 3, 0, 0. 0, minus 14, h plus 18, the 0. 18, 0. We can just scaling second row. Second row times 1/3, so we have this one. 1, negative 3, 3, 0, 0, 1, 0, 0. 0, minus 14, h plus 18, 0. The next, how can I make the minus 14? Same, first row, second row, third row. I can do that. Third row plus 14 times second row. The 0, minus 14, h plus 18, 0. 14 times second row is 0, 14, 0, 0. And add 2 rows, 0, 0, h plus 18, 0. So we have this one. The first row, 1, negative 3, 3, 0. Second row, 0, 1, 0, 0. Third row is 0, 0. h plus 18, 0. So what happens? We have pivot. First column has a pivot. Second column has a pivot. So this is what? Linearly dependent. What does it mean? Third row doesn't have a pivot. No pivot. No pivot. What does it mean? h plus 18 equal to 0. So H equals minus 18. That's it. So this is answer of this question. The next tip, the linearly independence of matrix columns. Assume that A is a matrix, A1, A2, AN, the AI's are vectors, like vectors. Think about the columns of A as vectors. Recall this one. Vector V1, V2, Vp in Rn is linearly independent. What does it mean? Vector equation has only the trivial solution. We can use this definition. The columns of matrix A are linearly independent. What does it mean? If and only if the equation AX equal to 0 has only the trivial solution. Does it make sense? Here, the next one. You can multiply this one times vector X. Times what? Vector X. Matrix A times vector X equal to 0. So what's that? This is same to the A1, vector A1, vector A2, keep going, vector AN times vector X is X1, X2, Xn equal to 0 vector. Sorry, 0 vector. So like this. So what does it mean? This is X1 times vector A1 plus vector X2 times, X2 times vector A2. So keep going here. Xn times vector AN equal to 0. This is exactly vector equation. Vector equation equal to 0. This vector equation has trivial solution. What does it mean? The columns of matrix A are linearly independent. Yeah, exactly same. So explained. So previous one, the same. Here, determine if the columns of the following matrix form a linearly independent set or not. So how can some check these kind of things? Like same. So do we have like free variable or not? This one has free variable. So what's that? Linearly independent. No free variable, linearly independent. We have a free variable, linearly dependent. So you can change this one to like echelon form. So what's that? So you just only, this is your first row, this is second row, third row. How can it be -2? So second row plus 2 times first row. The second row is the -2, 4, -6, 2. The 2 times the first row, 2 minus 4, 6, 4, and add it. So what's that? 0, 0, 0. This one is 6. So we have 1, -2, 3, 2. Second row is 0, 0, 0, 6. Third row 0, 1, -1, 3. The next you have to interchange second row and the third row. So we have 1, -2, 3, 2. 0, 1, -1, 3. 0, 0, 0, 6. So what happens? We have pivot. First column has a pivot. Second column, pivot. Third column, no, 0. The first column, yes, pivot. What does it mean? The third column doesn't have a pivot. What does it mean? The x3 is free variable. So what's that? The columns of the matrix, the columns the columns of, you can write this matrix like A, columns of matrix A does not form, do not form a linearly independent set. It's good. The columns of A do not form a linearly independent set. Yeah, this is like the exact things. Only check what? Free variable exists or not. This is like a main idea. Pivot, every column has a pivot or not. Set of one or two vectors. The set containing only one vector v is linearly independent if and only if v is not the zero vector. Proof. The only one vector v is linearly independent. So I can, what does it mean? The x1 times v equal to 0 has only the trivial solution x1 equal to 0. We can assume that vector v equal to 0, what happens? x1 v equal to 0 for any x1. So one example is 5 times vector v equal to also 0 because vector v is 0. So what does it mean? 5 is non-trivial solution. Non-trivial solution. So what's that? Not linearly independent. Was it like this one? Vector v is linearly dependent, is right? So it doesn't make sense. So the v is linearly independent if and only if vector v is always non-zero, right? This is like only one vector. Second one, a set of two vectors v1, v2 is linearly dependent and lists one of the vectors in a multiple of the other. This is linearly dependent. A set of two vectors v1, v2 is linearly independent if and only if neither of each vector is a multiple of the other. So this is like a whole idea. So why this is true? So one example, this is like two vectors, v1, v2 is linearly dependent. Linearly dependent. So what does it mean? The x1 times v1 plus x2 times v2 equal to 0 has a non-trivial solution. This is exact meaning, linearly dependent, non-trivial solution. So we can assume that x1 is not equal to 0. Just assume, because non-trivial solution. So you can just solve this equation for x1 and v1. You subtract the x2 times the vector v2 from both sides. x1 vector v1 is same to x2 vector v2 divided by x1. What's that? Vector v1 is x2 over x1 times vector v2. So what's that? Exactly. N leads to one of the vectors is multiple of the others, right? The u1 is the multiple of vector v2. Yeah, this is like exactly linearly dependent. Why is it like linearly independent? Here, neither of each vector is a multiple of the other. Right? This is like only two vectors. Here, linearly independent or dependent. Here, Vn and V2. What's it like a V2? The first one, A. What's a vector V2? The 6, 4. The exactly same to 2 times 3, 2 times 2. So we have the 2 times vector 3, 2. So what's that? This is 2 times vector v1. The v2 is the multiple of vector v1. So what does it mean? So here, linearly dependent. This definition. So we have vector v1 vector v2 is linearly dependent. So what is like this one? The vector v2 is like a second on b, exactly. 2 is a common factor. Factor was that 2 times 3, 1. 3, 1 is not equal to 3, 2. What's that? The v1 is not equal some constant times vector v2. Impossible. Vector v2, this is like b, is not equal to constant times vector v1, the not multiple of the other vector. So what does it mean? The vector, the v1 and vector v2 is the linearly independent. The linearly independent. This idea. So you can prove this one, use another method. So was it like B? Was it like another method? Another method is you can change it to the matrix. Vector v1 is 3, 2 here, the 6, 2 is here, and 0, 0 augmented matrix, so like this. So this is like a first law, this is like a second law. So how can change this kind of things? The interchange, the two things better. Interchange the 2, 2, 0, 3, 6, 0. The only some the like scaling. The first law times 1 over 2, we have 1, 1, 0, 3, 6, 0. This is the first law and the second law. So how can I make the 3? The second law plus 3 times first law. So we have 3, 6, 0. Negative 3 times the first law. The negative 3 times the first law is negative 3, the negative 3, and 0. And add it. So we have 0, 3, 0. So we have echelon form 1, 1, 0, 0, 3, 0. So what does it mean? So don't think about this is like a constant term. The first column has pivot. Second column has pivot 3. So what does it mean? No free variable. No free variable. So what's the answer? Linearly independent. This is the whole idea. The either is fine. The set containing the zero vector. A set of vectors v1, v2, vp in Rn that contain the zero vector is linearly dependent. Proof. The recall. Was it like a definition of linearly dependent? So vector equation has a non-trivial solution. So suppose that v1 equal to 0 because this is assumption. Contains the zero vector. The zero vector is v1. Just assume. So like this. Consider a vector equation x1, v1, x2. So like this equal to 0. So what's like a possible solution? Do we have it? The one possible solution is here. This v1 is always zero vector, is right? This is always zero vector. We can choose. X1 is number 1. X2 equal to 0. So XP is 0. What is it like a vector X? Vector X is, first one is 1. Second is 0. All things is 0. This is one non-trivial solution. This is non-trivial solution of vector equation. Non-trivial solution. What does it mean? Linearly dependent. That's it. This is like a proof of a theorem. So a set of vectors v1, v2, vp that contain the zero vector in linearly dependent. This is very important. The zero vectors always linearly dependent. Yeah, this is proof. Like this. So next one. A set contains too many vectors. A set contains more vectors than there are entries in each vector. Then the set is linearly dependent. That is, any set the vector v1, vector v2, vector vp in Rn is linearly dependent if p is greater than n. So proof. As like matrix v1, v2, vp, then A is n times p matrix. X equal to 0 corresponds to a system of n equation in p unknowns. There are more variables than equations because p is greater than n, right? So there must be a free variable, and then ax equal to 0 has a non-trivial solution. Therefore, the columns of A are linearly dependent. So this makes sense? I'm gonna give one example. This is Rn equals like 2, R2. So what's the V1? The V1 is like, so just an example. I'm gonna give one example like this. This example is like better for understand this problem. Vector V1 is like 1, 2. The vector V2 like this. Vector V3, we have the negative 3 and 1, so like this. So we have 3 vectors. So this set is linearly dependent or not. So how can you know that? So you can change this one to the like equation x1 vector v1 plus x2 vector v2 plus x3 vector v3 equal to 0. So what's that? So we have this one is like this. You can plug this one into here, this one into V2, this one into V3. So we have the 2 linear equation with 3 variables, like this one. x1 plus 2x2 minus 3x3 equal to 0. The one equation. The second equation is 2x1 plus, here bottom one 3, the 3x2 times 1 times plus 1 times x3 equal to 0. How many variables? We have the 3 unknowns. The 3 unknowns, the n equal to 3. No, this is p equal to 3. So p equal to 3. How many equations? We have 2 equations, like this is R2, n equals 2. So here, more variable than equation, right? In this case, we always have a free variable. So columns, you can just check that these kind of things, we have infinitely many solutions. So columns of A are linearly dependent. This is very important. So here, this example. This is like A is linearly dependent or not. So here, was it like this one? This whole vectors in, this is like A in R3, is right? This is R3. The first, second, third on R3. 3 is N. How many vectors? 1, 2, 3, 4. So we have P equals 4. The number of vectors like greater than the exactly, this is like a dimension 3. So 3 equals n. So we can use previous theorem, linearly dependent. So linearly dependent. That's it. This is like A. What's like B? The second column is 0 vector, the 0 vector. So second column has 0 vector. Second column has the 0 vector. So what does it mean? We can use previous theorem. This one. So set vector, this one contains 0 vector. What's the answer? always linearly dependent. So this is zero vector, automatically. This one is linearly dependent. So this is like a whole idea for solving these kind of problems. Okay, so this is all for today's lecture. Thank you for watching my video. If you have any trouble, any question, stop by my office in my office hour or send the email to me. I always help you. Okay, thank you.